Okay, welcome to this lesson on friction. That's lesson 2 in year 7. So if you could please date your work, so we've got a record of when you completed this lesson. And the objectives today. I can conduct an experiment to measure friction on different surfaces. I can explain what is meant by the term independent and dependent in an investigation. So obviously you probably won't be able to do the experiment yourselves, but hopefully we can show you exactly what you missed out, and you can have some ideas of how that experiment would go, and maybe we can have a little go at doing it when you're back in lesson. So rub your hands together, they get hot. Why is this? Okay, well I'm rubbing my hands together right now and they get hot. Well, fundamentally, I suppose, coming back to the last lesson, we did a little bit about forces, and one of the forces that comes into play when we rub our hands together is friction. And what, in effect, I suppose in a physics term, we are doing work against the friction. The friction is trying to stop the movement, and if you actually put your hands really hard together, it's hard to move them because they generate so much friction. And that's really what we're going to investigate at different ways. We're going to change some things in investigation and see how the friction is affected. So, how are we going to do this? Well, today you would be using, if you're in lesson, these bad boys down here, and you can see they've all got, if you can't make, you just notice they've got ends on them there, and these are all measuring newtons. They are force meters. Okay. They are sometimes referred to as Newton meters because Newton is the unit of force that we use in physics, the SI unit. That just means System International. So it's System International, it's sort of like a French derivative. So we say SI unit, and it is in newtons. So forces, and it just refers to the international system for naming of units, SI. So this is fundamentally the experiment that I want people to do in class. We are going to use a force meter, Newton meter, and we are going to drag a shoe. And what actually happens when you drag a shoe like this, it generally doesn't move initially. And then if you drag it a little bit more, eventually it starts to move. And what you actually notice to keep it moving, the force more or less remains the same. If you're just doing it gradually, so it's just moving, you will find that the force required to get it moving. And that really, what you're measuring there, the force to just keep it moving, is when the force is equal to the friction. So there is a video, if you cannot do this at home because you don't have a Newton meter, I mean if you do have a Newton meter at hand, that's probably unlikely, then feel free to do this experiment. But if you don't, go and have a look at this YouTube video. I'll put a link in the description as well. So fundamentally, we're going to place different surfaces. And the sort of surfaces we're going to look at, we're going to use the table, carpet, concrete, and grass from outside the lab, and you're going to measure it. Now, clearly, if you haven't done this, you can't do it, then I'm just going to show you someone else's results. So this was a table, the carpet, the bark, must have found some bark outside from a tree, concrete, and grass. And we can see in this student, you got 2.5 newtons, 4 newtons, 5 newtons, 4.5, and I'm just going to indicate here something that actually some students, you don't actually need that there because you might spot. So this particular student, something you can make a little note on yourself. If I go up to here, you can see that the newtons has already been included in the table already. So on this particular work, it's very important that you don't double up on your units. You don't want to be writing that in there. It's not a big mistake, but as we saw it there, I could correct that. So let's go. Now that would take a little while, that experiment, but which surface caused the most friction? Which surface caused the most friction? In this particular set of results, it was grass. Why do you think this? Why do you think that was? Have a pause. Yeah, it's because the force, really, we're measuring the force that we pull on. And the force that we pull on when we're pulling it in that way is equal to the friction. So what I'd like you to do now, go onto the internet and see if you can find a little diagram to explain how friction comes about, and put a little diagram see if you can make a little diagram and put that in down here, please. Okay. Right. So this investigation, let's just go back to this investigation. Actually, let's talk about what we did. So in this investigation, what did we do? We changed the surfaces and we pulled the shoe along. Now, if we wanted to, we could have done different investigations. We could have really kept the surface the same. We could have just done it on the carpet every single time and used a different type of shoe, in which case we'd be investigating which shoe had the biggest friction. Another type variation of this experiment is we could use the same shoe and the same surface, and we could start putting weights into the shoe, and we could see whether adding weights to the shoe increased or decreased the amount of friction. So with very similar equipment, we could conduct rather different investigations. And when we do an investigation in science, what we do is we change things to see if other things depend on them. So what I want you to write in here, when we have an independent variable is something that we change in experiment. A dependent variable is something that we measure to see if it changes. So if you could write that in there, so you got it clear in your notes. What is an independent variable? The independent variable is the variable for which values are changed or selected by the investigator. That's you. The dependent variable is the variable of which the value is measured for each and every change in the independent variable. So hit pause now, make sure those are completed in your booklet in the right section. Very good. So in the investigation that our friend did up below, what were the independent and dependent? Well, let's look at this. What was this student changing? He changed the surface. So in this investigation, the surface, the surface was what I would call, the surface was the independent. And when they changed the surface, they kept the shoe the same, they kept the weight of the shoe the same, they needed different amounts of force, and that's just what came out of the investigation. No one decided it, that's just what came out. So if the force needed to pull the shoe, or in fact the friction, which was what the force board needed to pull the shoe was the dependent variable. So you can either have a couple of things around down here. You could write down the force required to pull the shoe, and that really in effect was our way of measuring the friction, and that was the dependent. Very good. So make sure you're clear on that. Go and watch the video again if you're not clear. So could we have made any other investigation with the same equipment? Well, if you don't, I was actually discussing that a little bit earlier. So there are other investigations with virtually the same equipment with very few modifications that we could do. So please rewind the video and go and have a look at that and get some ideas down there. Explain what those investigations would have been. Now, if you didn't manage to find a video, a nice diagram to show friction, this is how I sometimes explain it. See this crate here? See this crate? Well, the crate, if you try and pull it that way, you really have these real rough little surfaces in here. And because even though the crate looks flat and the surface looks flat, really what you're doing is you're really getting just contact forces as you rub things across it, as you try and move the crate in that direction. All these little cracks and imperfections in the surface are going to really just stop it moving, and that is really what is the cause of friction. So have a go at trying to do the experiment. If you can't, please go and have a look at the video that I referenced earlier on. It should be the description, will be found in the description. You can also find in the link. So please go and have a look at the video if you haven't managed to do the experiment at home. There we go. There's the link that you need to do to go and watch the video, and you can also find it in the description to this video. Okay, so unfortunately, if you haven't been out of lesson, you should at least be able to get up to date and be ready for lesson 3. Thank you. Bye bye.